Welcome to the companion video to the University of California Division of Agriculture and Natural Resources, publication number 8092, entitled Guidelines for Residual Dry Matter on Coastal and Foothill Rangelands in California. This publication is available by either contacting your local University of California Cooperative Extension Office or through the internet at anrcatalog.ucdavis.edu/pdf/8092.pdf. The objective of this video is to show rangeland owners and managers the what, why, when, where, and how of using residual dry matter, or RDM, to monitor rangelands in California. Specific RDM guidelines or objectives for 3 types of California grasslands will also be explained. Residual dry matter, or RDM, is a standard used by land management agencies for assessing the level of grazing use on annual rangeland and associated savannas and woodlands. RDM is the old herbaceous plant material left standing or on the ground at the beginning of a new growing season prior to the first significant rain. Properly managed RDM can provide a high degree of protection from soil erosion and nutrient losses. Other benefits include improved forage productivity, seedling germination and establishment, water infiltration, wildlife habitat, livestock forage availability, reduced fire hazard, nutrient cycling, plant species composition, soil stability and structure. The standard assumes that the amount of RDM remaining in the fall, subject to site conditions and weather variations, will influence subsequent species composition and forage production. Combined effects of the previous season's forage production, breakdown over summer, and its consumption by grazing animals of all types. Without grazing during the dry summer or fall, RDM will decrease in weight on average 7% per 30-day period from peak standing crop till the first germinating rain in the fall. Several agencies have successfully applied the RDM-based method for managing grazing intensity. Included are the Bureau of Land Management, the Natural Resource and Conservation Service, the National Park Service, the U.S. Forest Service, and the San Joaquin Experimental Range.
In the 1950s, range professor Harold Heddy had the idea that instead of measuring utilization by livestock with complex and often inaccurate cages comparing grazed and ungrazed use, that simply looking at the amount of what he called natural mulch left on the ground would be a better indication of the response of rangelands to grazing. So he designed an experiment at the Hopland Field Station in Northern California. The results of that study suggested that the amount of what we call residual dry matter now left on the ground in the fall had a profound effect on subsequent forage production and the composition of the grassland. This was published in a landmark publication in 1980 that was quickly used by UC Extension to produce a set of guidelines for users to apply these concepts. Those have been applied through many federal agencies and landowners. It's now the most common way of managing grazing intensity on California annual rangelands. On annual rangelands, the general guidelines for grazing include levels called light, moderate, and heavy grazing, and those are now tied into specific levels of residual dry matter and based on the research that's been done in the past.
So for the purposes of residual dry matter, we often separate the California annual grassland type into 3 different categories. The first would be the dry annual grassland, typically receiving 12 inches or less of rain, where the predominant vegetation are the annual species, grasses, legumes, and forbs. That does sometimes have some oak component or other woody shrub species component, but the vast majority of the vegetation are the annual species. The second would be the annual grassland or oak savanna or hardwood rangeland, where we have a much higher component of woody species, typically the oaks and some of the shrub species, but still the annual vegetation comprises the vast majority of the understory vegetation. And the third would be the coastal prairie, typically in higher rainfall areas, obviously along the coast. There we often see a significant component of perennial grass species along with the annual species. And there too we commonly find some oaks and some other woody species such as shrubs intermixed with the annual vegetation. To account for the differences in these growing characteristics, the differences in slope, soils, and other growing characteristics, we developed a series of residual dry matter scorecards or tables to demonstrate the differences in those characteristics, and that lists the minimum amount of residual dry matter that was recommended to be left at the time of the first fall germinating rains. Tables 1, 2, and 3 have that information and those measurements and have the recommended amounts of residual dry matter for each different situation, growing area as well as the slope and canopy characteristics.
There's several methods of estimating residual dry matter, or RDM.
One of the primary methods for determining RDM is to clip a plot or a quadrat, and we usually end up clipping lots of quadrats to improve precision. And in doing that, we take into account a slope, a rocky area, under a tree, out from under a tree. But in the final analysis, we have to clip lots of plots.
And this method that we're demonstrating here is how the estimations were arrived at in the companion publication and what we're presenting to you in this video. So this is the method that was actually used.
Okay, so now we're going to clip a plot. And the first thing you do is you take the bag you're going to put the clip material in and weigh the bag before you put anything in there to get a tear weight. And these bags weigh 21 grams. And then hopefully you have an able assistant who's going to write the number on it. It's always nice to have two people doing this rather than one. The next thing you do is you clean the plot out. You want to get any summer annuals out of the plot, which we don't have in this plot, but if there was a star thistle plant there, we'd take it out, or tarweed plant. The other thing we want to do is get the oak leaves out. So we have a few of those in here because we're pretty close to an oak tree. And so we pick those out, get those all out so they don't end up in the bag. We don't want to weigh those. And then we're about ready to clip. And then we have to do one more thing, and that's to make sure that we only clip what's rooted inside of the quadrat. So we kind of go around and pull the material that's rooted outside the quadrat out of the plot, and in reverse, we make sure everything that's rooted in the plot is inside before we start clipping. Get it all in there. And then we're ready to clip. And so when we clip, we want to clip as close to the soil surface as we can get without disturbing the soil surface. And it takes a couple of minutes to do this. Keep the trash out. Okay, and after the plot's clipped and all the material's in the bag, you want to weigh the bag and the clip material. And this weighs about 60 grams. Now before we clipped, we weighed the bag when it was empty and it weighed 21 grams. So if we subtract 21 grams for the bag from 60 grams for the whole sample, we come up with, 39 grams. And we're going to multiply that by 96.
As you can imagine, clipping plots on a large ranch can be very time-consuming and costly. Using a combination of clipping and visual estimation of RDM can reduce these costs.
Researchers have come up with a different method or procedure to estimate RDM, and one of those methods is called the comparative yield method. It essentially uses visual estimations and minimizes the number of actual plots you have to clip. It's really been benefited by the advent of new technology like tablet computers and the electronic type programs, spreadsheet programs for data entry. The procedure basically is done with teams of two. Although it can be done with one just as the clipping was done, it's a much quicker method if you use a team of two. One of the team members is the observer or evaluator. The other team member is the data recorder. Okay, there are basically three steps to using the comparative yield method. The first step is to take a representative site, assign a ranking of 1 to 5 on the separate quadrants, 5 being the most residual dry matter that you would find, 1 being the least. The second step is working with the observer evaluator. You essentially collect 50, 100 or more points where the observer ranks those observations on that 1 to 5 scale. And the last step is to set out 15 or more calibration quadrants where the observer goes out, ranks those again on a 1 to 5 basis, and the team comes back and clips and weighs those 15 or more calibration quadrants, just as was done on the small plot clipping. Okay, to teach you this first step of this procedure, we're going to do a little role playing. I'm going to be the student and Mel is going to be the instructor here, and he's actually going to show you how you would train somebody in the field to do step 1 of the comparative yield method. Mel?
So step 1 of the comparative yield method is to lay down quadrats that represent the ranks of 1 through 5, and so you'll have 5 quadrats. And just before you do that, you kind of look around the area that you're going to work in, that you're interested in determining RDM for, and you get an idea of what the highs and the lows are. And the first thing you want to do once you have an idea of that is find your low. And so I've identified a low right about here. And so that's the lowest RDM I expect to find out here today. And then at the other end, I try to find the highest that I might find out here, and it might look about like that. Okay, and then, so the low one is going to be rank 1, and the high one is going to be rank 5. And then the next step is to find one right in between. It might look like that. And that's going to be rank 3. And then we're going to split them again, and so we want to find one that's between 3 and 5. And you know, it might look like that. And then we want to find one that's between 1 and 3, and maybe it's going to look about like that. Okay? Once everybody's satisfied with them, then you look at them carefully and get in your mind what 1 looks like. And then get in your mind what 5 looks like. And then get in your mind what 3 looks like. And then get in your mind what 2 and 4 look like. And then just go through them a few times until you're pretty confident that as I walk across the landscape, I can identify a 1, a 2, a 3, a 4, and a 5. And then you're ready to move across whatever landscape you've selected to do your determination in and take an estimate every few steps if you want to. You can get hundreds if you want to. And the way you do that is we could take these quadrats that we've been using for our references and we could throw it in front of us and we could look at that and say, well, that's a 3. Okay, then pick it up, put it in another position and say, well, that's another 3. Okay, now you can imagine if we're doing hundreds of these that there's going to be a lot of bending over and picking up. And so to save energy and possibly your back, we've put a handle on a square foot plot and we just set it in place and say that's a 4, and then we move on to the next one, and the trusty recorder's writing these down as you go, and you can go pretty fast. And so there's a 2, there's a 2, there's a 3. You don't want to go any faster than your recorder can write the data down. So there's a 5, there's a 4, there's a 3, here's another 5, here's a 5.
Okay, now we're on to the step 3, or the calibration phase, and Mel's going to explain what we do in the field to get the calibration set up.
So we're ready to build our calibration equation, and so we put a quadrat on the ground, and we're going to put 15 of them on the ground here eventually. And this is quadrat number 1, and it has a rank of 3. and John's been preparing a bag, so I leave a bag here. We're not going to clip right now, we're going to clip in a little while, but I leave a bag here that has, this is bag number 1, and this plot receives a ranking of 3. And we do that several times, but here's my second one. This is going to be bag number 2, and it's going to have a rank of 5. And so John's prepared the bag, we leave it here, and we go ahead and do the remaining number 15 or more. And then we're going to come back and we're going to clip these plots, put the material in the bag, so we have a known clipped weight that we're going to get from the bag to go with a ranking of, in this case, 5. And at the end of the day, we'll have 15 or more of these that are spread across some very low ones that are ranked at maybe a 1 or a 2. Some at the high end, 4s and 5s. We'll have the weights for them. We can put that all together in a spreadsheet and do some calculations to come up with a conversion equation for converting the ranks to an actual weight.
Fact of the matter is we've created a spreadsheet that's the same spreadsheet that was used to record the data in the field when I was doing the actual recording. And in that spreadsheet it has the necessary formulas to calculate the regressions, establish the relationships between the ranks and these small plot weights, and convert to pounds per acre.
Spreadsheet software programs have the ability to calculate a linear regression between pounds per plot and comparative yield rankings. A blank calibration spreadsheet and 2 blank assessment spreadsheets is included on this DVD.
Perhaps the easiest way to estimate RDM is with the use of standard guides or photos. This is done usually, again, prior to the first fall rains, and essentially the photos are compared with what you see on the landscape. So you take the photo guide and look at it and compare what they are, and then estimate the RDM from the actual photo guides and record it. This is the method that's used by most ranchers in California. It's the simplest and easiest method for them to use.
Various reference photos of grazing intensity standards have been developed for many parts of California. The 3 sets shown here are for the Central Valley foothills and came from the San Joaquin Experimental Range. The moderate grazing is recommended for best livestock performance and rangeland protection for this region of California. It should be noted that moderate grazing will provide more RDM than listed in the scorecard tables shown earlier in this video and its companion publication. Another excellent color set in booklet form is available from Keith Gunther's Wildland Solutions website. These standards show RDM classes for monitoring on a site producing RDM is more than 1,600 pounds per acre. RDM is between 1,200 and 1,600 pounds per acre. RDM is between 800 and 1,200 pounds per acre. RDM is between 400 and 800 pounds per acre. RDM is below 400 pounds per acre. RDM has been removed by fire and is below 100 pounds per acre.
In some parts of California, photo guides are not as well developed as they could be on the California annual rangeland grasses. So it is possible to actually make your own photo guides. To do this, it's very, very simple. You need a date-back camera. Digital works great for this. You need a tripod. You need to manufacture what we call a robopole, which is nothing, in ours, it's a handmade piece using a piece of about 2-inch PVC pipe. And we've used black tape to mark inch measurements on it. This gives us a height of our forage. And then we place the tripod facing it a northern direction. We set the tripod at about a 5-foot height, and we take 2 pictures. The first picture is going to be at about 20 feet away from our frame and our robopole, and then we're going to move the tripod in to 10 feet and take a closer view. Oftentimes the plot frame disappears in the forage that you have, especially if it's got a high RDM. And it's kind of nice to have some reference devices. Typically people use golf balls, softballs, or any kind of baseball, and it gives you an idea of the actual height of the vegetation that's represented in the picture. So again, we can take that first shot, and then we can move in to a 10-foot to about 10 feet. And through the viewfinder, we try to capture the robopole and the plot frame so that we get a good representative photo. Once you've done this, you have the ability to create your own photo guides on your ranch or your piece of property, and it'll be much more valuable for you on a yearly basis, and you get the seasonal variation recorded as well. And you establish your own guides.
If taken annually and done on a pasture-by-pasture basis and transferred to maps, a snapshot of utilization is available. This type of map provides a history of use and identifies problems and successes for the entire ranch. It also documents good stewardship of your range management. We hope you found this video useful and that you are more comfortable in using RDM in managing your California rangeland. As was mentioned, earlier copies of the blank spreadsheet and the comparison publication are included on this DVD if played on your computer.